All right, so we're going to be looking at the graphs of sine and cosine. So we'll be at the bottom. We will graph tangent, but that's going to come later. All right. So what I'm going to do in these notes is I'm going to kind of just generalize what we just did with the fettuccine, just kind of in a more simple format. And then I'm going to point out two things that I didn't talk about earlier that are really important to know about the graph. So we'll start off with sine. I'm going to put some key points in here for sine. So we have 0, pi, and 2 pi. And the range here is going to be -1 to 1. Thinking about our unit circle, that's as high and low as we can go. And then you just need to sketch in a curve. It doesn't have to be perfect. Though mine looks pretty perfect. And you can imagine that this is going to continue on, but we're just going to graph one cycle of it. Alright, so a couple things I want to point out here. The first one is what we refer to as a period. This is called a period. We can also refer to this as a cycle. Either way, it's the amount of time it takes to complete one cycle. In this case, it's 2 pi. We talked about how it would change if you had a horizontal stretch on it. Now, before we talk about some of the deeper things that are going on here, I want to draw the cosine graph so we can kind of contrast the two. So move over to the right and we'll look at cosine. Set up the same axes. The difference with the cosine graph is it started in a different place. It actually started up at 1. And it went through pi over 2 and 3 pi over 2. And there's this kind of one cycle. And then it will repeat. And there's a couple points I want to highlight for you. And it's really where they start. So this point here starts at 0, 1, the cosine graph. And the sine graph starts at 0, 0. I want to box this so you can see it. Write this, just for this sake, as 0 pi, because that's what it is, comma 1, for cosine. And we'll write sine as 0 pi, comma 0. Unit circle. So it might help here. We want to think unit circle. Okay, where to begin. Other than that, once you know where to start, you can move forward with it. All right, here's the next part of this, which I haven't talked about yet. I talked about period length. Now we're going to talk about a new term, which I'll make up here. This length, the height of it, is called amplitude. And your amplitude, what would the amplitude be here? 1. It's a distance of 1. Well, it's going to go up 1, but it also goes down 1. We always refer to amplitude in terms of absolute value, though. It'll just be positive number. Let's see. Characteristics. All right, so this is going to be true for both graphs. Your domain, and I want to really be specific here. It's not our x values. This is my input. Let me say my domain or my input. Anybody remember what we talked about at the beginning of class, what my domain is? It's not x anymore. It's theta, so it's radians or degrees. Very good. It's radians or degrees. You can think about your x-axis. And what's my domain going to be for these graphs? Negative infinity to? Perfect. Now, I mean, this is, in reality, this is how the waves in the ocean are, right? There's always waves coming in. But we will restrict the domain if we want to look at certain parts of it. Okay. Next part of this is range. You can do it right underneath it. Range is my output. And the range, we talked about earlier, isn't necessarily y. It's your x or y coordinate. And I want to draw this out a little bit further so you guys can see. If you're dealing with sine of theta, do I care about my y coordinate or my x? That's my y coordinate, right? This is my y coordinate. If I'm dealing with cosine, I'm looking at my x. They're both outputs. It just depends on which one I'm asking for. What was the range on the sinusoidal function? -1 to 1. Perfect. Questions?